So we're starting lesson 4.9 today, and we're only going to cover one thing in it today, and that is the slopes of parallel lines. Lines are parallel when what? What's parallel mean?
They're like railroad tracks.
They're like railroad tracks. They're never right next to each other. They never touch. They never cross. Every point on the line is equal distance from another point on the other line. They will never meet each other. Okay, well, then let's talk about what kind of lines, how can we tell if lines are going to be parallel according to their equations? Did you have something, Nita? No? Okay. Non-vertical lines are parallel. What's a non-vertical line?
One that's not going up and down.
Okay, this is vertical, right? So when we say non-vertical, we mean any other line, including a horizontal line, any other line that's not vertical. When we talk about non-vertical lines, they are parallel if and only if they have the same what? Slope. They have to rise and run at the same rate. Each of them has to have the same slope so that they're rising and running at the same rate. That way they will never cross. And then what do they have to have that's different though? Because if they can't ever touch, they can't be on top of each other.
Same Y value?
Why what?
Intercept.
Intercept. They have to have a different y-intercept. If they have the same y-intercept and the same slope, then we'd be saying they are the same line. And they can't be the same line, or they would be on top of each other. Parallel lines can't touch each other. So as long as two lines have a different slope and a different y-intercept, and they're not vertical, we can count on that they will be parallel. Well then, what about those vertical lines that we left out of this definition? A vertical line is parallel to another vertical line. It'll be parallel to another vertical line.
Different x-intercept.
Yeah, vertical lines don't cross the y-axis, they cross the x-axis. So they have to have different x-intercepts.
Yeah.
Anybody remember what the equation of a vertical line looks like? What's missing in the equation of a vertical line? There are no y's, not y-intercept, there are no y's, period. X equals a number. Remember, all the points on a vertical line have the same x value. So if we have a vertical line that is crossing the x-axis at positive 3, what would the equation of that line be?
X equals 3.
X equals 3. Its x-intercept would be 3. Every point on that line would have an x value of 3. So a vertical line has an x equals its x-intercept, really, is what it is equal to, or what its x value is in all of its points. So those guys are parallel to each other. Okay, you need your books open, because we're going to eventually use them anyway, but I want us to see what do the directions actually tell us to do for number 2 on page 297. We're doing some problems right now, just like what you're going to do in your homework. So what do the directions tell us to do? No, number 2. Identify which lines are parallel. Now you don't get to just look at them and say, okay, this one and this one are you're going to have support for it. So that's what we're going to do here in number 2. Here's getting our support. Number 2, we have y equals, you're right here. And patience, you're next to it. Okay, so identify which lines are parallel. We're going to show support for them. In other words, whether they meet the standards we just stated up above. So y equals 6. What kind of a line is that? That's a horizontal line. When there's no x's, now we have a horizontal line. So what's the slope of a horizontal line? 0. And what's its y-intercept? 6. It's going to cross the y-axis at 6. Okay. Our next equation, y equals 6x plus 5. What form are these equations in so far?
Slope-intercept form.
Slope-intercept form. And in their slope-intercept form, we can go right to identifying their slope and y-intercept. So this one's in slope-intercept form also. So what's its slope?
6.
And its y-intercept is
5.
5. Are those two parallel?
No.
Okay, why not?
Because it's not a horizontal line.
Okay, what's
So
a horizontal?
eventually it's gonna cross.
Yeah, so a horizontal line is gonna have to be parallel to
Another horizontal.
another horizontal line, isn't it? Okay. Plus they have different slopes, don't they? Okay. How about y equals 6x minus 7? What's its slope? 6. And its y-intercept is negative 7. We can change that to add the opposite, mx plus b. Y equals negative 8. What's its slope?
0.
0. What's its y-intercept? Negative 8. Okay. So, the standard is this. If it's not a vertical line, they have to have the same slope and different y-intercepts. So, do we have any sets of parallel lines?
Yes.
Hey, which ones?
The second and third.
Okay, so we're going to state that y equals 6x plus 5. And the third one you said, y equals 6x minus 7, are parallel. And our support for it is up above. We already did all that. We identified the slope and the y-intercept because they were all non-vertical lines. And so that support helps us say, okay, those two are because they have different slope, the same slope and different y-intercepts. Are we have any other sets of parallel lines in this group? Nita?
The first one and the last one.
The first one and the last one, because y equals 6 and y equals negative 8 have the same slope and different y-intercepts. In fact, what kind of lines are these? These are horizontal lines. We don't really need, I guess, punctuation there. We're not really writing sentences. Okay, do we have any other sets of parallel lines out of that group? No? Okay. So any questions on what you have to show me? Do you think I'm going to stamp your paper tomorrow if the only thing you have is this part right here? We're going to stamp your paper tomorrow? No. Support. Now, you can shortcut it this way. You can say, oh, well, we know that slope is m, and we know that y-intercept is b. And does anybody happen to know what the symbol is for parallel?
Isn't it two lines that are just right next to each other?
Yeah, like this. This means parallel. That's a shortcut way of writing parallel. Okay. Okay, let's look at number 3. Is the first one in slope-intercept form?
Yes. No.
Yes.
Yes.
Y by itself?
Yes.
Okay. And is it a positive 1y?
Yes.
Yeah, so then it's in slope-intercept form. What's its slope?
3/4.
3/4. Okay. What's its y-intercept?
-1.
Negative 1. How about the second one? Is it in slope-intercept form?
Yes.
Okay. What's its slope?
-2.
Negative 2. What's its y-intercept?
0.
0. Okay. How about the third one? Is it in slope-intercept form?
No.
Do we have to put it in slope-intercept form?
Yes.
Okay. How do we know we have to?
Because first off, you have y subtract -3 or subtract 3, so y's not by itself.
Okay. But do you think we ever can get the information we need from point slope form?
Yeah.
What do we need? We need the slope. Can we get the slope from this?
Yes.
We already can get the slope, but what can't we get?
The
The y-intercept, unless what? If this was 0 right here, would we have the y-intercept? Then we actually would have it, but that's not 0. So we have to put it in slope-intercept form. So let's do our distributive property. Change this to add the opposite. So we have y take away 3 equals 3/4 x plus what? 3/4 of 5. Well, let's just do it like this, you guys. Let's take 3 times 5, 15, and then we have that 4 downstairs. What's a positive times a negative? Negative.
15/4.
So it's a negative 15/4. Also, let's just take that now and let's make that into a mixed number because we're going to have to add 3 to both sides, and it's probably going to be friendlier as a mixed number. Negative 3 3/4. Because we're trying not to use our calculators, remember? Now we do what to both sides?
Plus 3.
Plus 3.
Now we add 3 to both sides. And we have y equals 3/4 x plus what?
A negative 3/4.
A negative 3/4. Okay, now we identify our m and our b. Okay, m equals
Or 3/4.
3/4. b equals
Negative 3/4.
negative 3/4. Okay. How about the next one? Y minus 4 equals negative 2 times x plus 2. Is the y-intercept in that one? No. So we're going to have to do the same thing. We're going to have to do our distributive property, get it into slope-intercept form. Your y equals negative 2x,
Yes.
or negative 2x plus 0. Right? Okay. So m equals
Negative 2.
negative 2. b equals
0.
0. Okay, now we can go and evaluate if we have any parallel lines. Do we have any sets of parallel lines? Remember the requirements. Same slope, different y-intercepts. Are any of those parallel? The first one and the third one. First one has a slope of 3/4 and a y-intercept of negative 1. After we get done putting the third one into slope-intercept form, it has a slope of 3/4, so the same slope but different y-intercept. So we can say those two are parallel. And we'll use their original names. So we'll say y equals, I don't want to have to keep scrolling that up and down. So we're going to say y equals 3/4 x minus 1, I found it, and y minus 3 equals 3/4 times x minus 5. That's how it started. Those two are parallel. We found out that they have same slope, different y-intercepts, so we can say they're parallel. Any others? Great.
Yes.
Any other parallel lines?
Second one and the second one and the fourth one.
And the fourth one?
Yes.
So, John is saying that this one and this one are parallel. Do you guys agree?
Or no, wait.
They're the same line, aren't they? They have the same slope and the same y-intercept. Can they be parallel? No. So, do we have any other sets? No, we just have that one set of parallel lines, don't we? Okay. So let me clarify one more time for you what's going to keep you from being mad at me tomorrow when I won't stand for paper.
Show me.
You have to do this. You have to show the slope. You have to show the y-intercept and the slope. And you can't take the shortcut, because what would have happened if you would have taken the shortcut on this one and said, oh, they have the same slope. This one and the second one have the same slope. They must be parallel. You didn't compare their y-intercepts, did you? So that's what can happen. These two are actually the same line. They're the same equation. One's in slope-intercept form, the other one's in a point-slope form. Same line. Remember how we said there's several different names. Okay, let's go to the back side and see what we're going to do now. Page 297, number 4. Page 297, number 4. What is it that we have to do?
Show that ABCD is a trapezoid.
Show that ABCD is a trapezoid. What makes a trapezoid?
4 sides.
4 sides.
Two parallel.
Exactly. One set of opposite sides are parallel. I think they gave you that hint, right? Okay. So here's what you you don't get to do next year in geometry, nor do you get to do this year. You don't get to look at something and say, oh, they look like they're parallel. It's a trapezoid. When it says show, that's the word they're going to use probably next year is prove that it's a trapezoid. And how are we going to do that? We have to prove that those two sides are parallel to each other. And how are we going to prove that?
They have the same slope.
If they have the same slope. So, what are the two sides that appear to be parallel?
AD and BC.
Okay, so line segment AD and line segment BC are the ones that we think are parallel. It appears that they are. So we're going to show that they have the same slope. Because if they have the same slope, we already are going to be able to tell. If they have the same slope, we're already going to be able to say they're not crossing the y-axis at the same spot. But we have to prove that they have the same slope. So, let's start with line segment AD. Let's start with that one. What are 2 points on line segment AD?
-2 and 5.
Try it a little louder for me.
-2 and 5.
-10 and 5.
2 and 5.
-2 and 5. And what's the other one? The same AD. 2 -1. Okay, we're going to find that one's slope first. So we're going to use our slope formula. M equals -1, take away 5, 2, take away -2. I get -3/2. Anybody else get that? Okay. So now, if these sides are parallel, what should happen when we do side BC?
Have the slope on the
Should have that same slope, shouldn't it? Okay, so let's do line segment BC. What are its ordered pairs that we can work with from that one?
4 and 5. 6 and 2.
Okay. Okay, go ahead and find the slope of that one now. You know how. We've been doing this for a while. Again, this is showing, this is proving that they are actually parallel. They may look parallel, but they may not be. You never know.
And they're parallel.
So, are they parallel? Because we use the same slope. So did we just show that it is a trapezoid? Yes, we did. So questions on when you have to prove parallelism. Okay, this is probably, the next thing we're going to do is probably the thing that challenges students the most. Okay, let's look at what does the directions say on page 298, where the problem 23 comes from.
Write the equation slope in the set form for the line that is parallel to the given line and that passes through the given point.
Write an equation in slope-intercept form for a line that is parallel to the given line. So this is our given line right here, people. It has a positive slope, so I'm just going to sketch it and say, okay, there's my given line right there. I already know its equation. And then I need a line that is parallel to that going through a given point. So it's kind of like saying, okay, here, the point that they gave us is right here. It's like saying that point is somewhere. We need the line that's going to go through that point that's going to be parallel to this one. So we need the equation for a line that's going to go through this point and be parallel to our given one. Well, what do we know about parallel lines again?
They have the same
They have the
slope.
same slope. So wouldn't that be kind of useful information to get from this one?
Yes.
So what's the slope of this line? 1/2. 1/2. Therefore, what's the slope of the parallel line going to be? 1/2. Okay, so now we gotta write an equation. We have the slope and we have a point. Have we learned how to write an equation of a line in
Yes.
slope-intercept form, given a point and a slope?
Yes.
Absolutely, we have two different ways to do it. You remember how I said it's going to get to the point, you get to pick which way works better for you, which way do you like better. So I'm going to show both of them, you take the one you want, okay? So we're working with this one right here, you should probably work right here, down here, okay? I just am going to show you the two different ways you could do this. So y equals mx plus b, you could start with that and solve it for b. Or you could start with the point slope form and substitute into that one instead. You get to decide which one do you want to do. So we have, for this one, we would put -3 in for y, 1/2 in for m, 4 in for x, and we'd solve it for b. Then when we were all done, we'd say, okay, now I have to make my equation. I'm going to know my m, and I'm going to know my b, so I can substitute them in, and then presto, I'll have my equation. That's one way to do it. The other way is the most recent way we've been doing it. We could do y take away -3 equals 1/2 times x minus 4. We could do our distributive property, get y alone. This one takes you directly to the slope-intercept form. So you pick the one you're going to do and do it right now. Okay? Which one do you want to do to get the equation of the parallel line? And it should be done in your notes. I'll finish mine up, you finish yours. Either way, we better get the same answer, all of us, right? This equation only has one slope-intercept form name. It's y equals 1/2 x minus 5. I prefer this way because it takes me directly to slope-intercept form. This way, there's nothing wrong with it, but when you're all done, when you get done, you're not really done yet because now you have to put it into the slope-intercept form, the slope and the y-intercept. So you can't forget that extra step you have to do. Here, there's no extra step to do. It takes you right to that equation. So now we are saying the equation of the line, and actually as it turns out, it probably would be below this line because it's got a y-intercept of -5, so it would probably be more like, I want it to be red, it'd probably be more like this. We just found the equation of that line right there. So our final answer is that y equals 1/2 x minus 5. That's the equation in slope-intercept form of the line parallel to the one given to us, going through ordered pair for -3. Questions? Okay, then here's our last one. Here's our given line. We're doing the same thing. We're going to write the equation of the line that's parallel to that, 3x plus 4y equals 8. Going through the ordered pair, same ordered pair, 4, -3, this one's going to go through. Can we get the slope from that given line right now? No. It's in what form? Standard form. That's worthless for slope. So we have to get it solved for y. Okay. This is where a lot of you aren't going to, this is where it's not going to go well for some of you. So make sure you're careful here. We got to get y alone. So we got to subtract 3x from both sides. 4y's alone. It's 8, take away 3x.
Take away 3x plus 8.
Or, well, you gotta be careful. Or it's -3x plus 8.
Yeah.
Right? So change it to add the opposite, and we see that's a -3x and a +8 And now we're going to divide every piece by 4. Every piece is divided by 4. So, our equation is y equals 2 plus negative 3 fourths x. And we went through all that work for what reason? Find the slope. We had to go through all that work to find the slope. What is the slope?
Negative.
Okay, so we know the slope of this line is negative 3/4. Well, if the slope of this line is negative 3/4, Nicholas, what's true about the parallel line? Shelby? Its slope is negative 3/4. It's got to have the same slope as that line. The new line has to have the same slope as the other one. It's got to be parallel to it. Now you get to make the decision which method do you want to use to get your equation in slope-intercept form. Do you want to use this method, or do you want to use the one on the right? Okay, I'm going to do my favorite one, which is point-slope form. What's 3/4 of 4?
3.
3. Okay, thanks. Helping me out. This is my equation. Is that yours? Anybody do the other method? Okay, did you get the same answer? No? We should. We should. We all have to at some point take 3/4 of 4. Hopefully we do that right, and then I don't know where else it might possibly go wrong, but okay. So this is what you have to do.